All right, so we're going to look at end behavior of rational functions. To talk about the end behavior, what we're going to do is we're first going to write the parent function for all rational functions. So if you would, please, all I'm going to do is do f of x equals 1 divided by x. I'm going to hit the home button. Okay, so let me change colors here because there we go. This is your rational function, parent function, 1 over x. So if you would just make a little graph of that. It's pretty easy. We're going to talk about some things. There is a line right here called the y-axis, and this right here is called the x-axis, and these are actually referred to as asymptotes. It's a very fun word to say if you're a math teacher. Sometimes you have a bunch of students and they kind of remind you of asymptotes. All right, that's a horizontal asymptote. All right, and this horizontal asymptote is y equals 0. And this guy right here is called x equals 0, and that's referred to as a vertical asymptote. And there are rules for vertical asymptotes and rules for horizontal asymptotes. There are rules of like how to find them. We're not going to go over all those rules today. I just want you to be aware of in life there are vertical asymptotes and horizontal asymptotes, and beware of them. Okay? All right. So right here, this right here, what's the number that makes that equal to 0? What number? 0. That's why we have a vertical asymptote right there at x equals 0. So anytime you make something equal to 0 in the denominator, you have an opportunity to create what's called a vertical asymptote. So now we're going to be talking about what's called end behavior. All right? So I'm going to erase all of this and start writing about end behavior. So right now, would you agree that as the graph goes to the left, the x values are going towards this concept called negative infinity? Okay. And as my x values are going to the right, I'm going to the concept called positive infinity. All right. Now, how about right here? Would you guys agree if I'm going this direction, I'm going towards the end, like it's going this way? That's called end behavior. As I go to the right, we call that going towards infinity. That's the end. Over here, this is the other end behavior. So we call this left end behavior. You're not going to believe what this is called. You're right. It's called right end behavior. So there's left end behavior and there's right end behavior. No, 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 no. This is not political. I no, no. All right. No, we're staying away from that because that just makes people angry. All right. And I can hear the walrus grunting in the background. Okay. All right. Now, right here. Can you guys write this, please? Because I want to make sure you guys understand what this actually means in words. X, this funny looking arrow, negative infinity. This guy right here means the word. It's not really a funny, it's just an arrow, but it means approaches. As x approaches negative infinity, what does f of x also approach? You're right. Yeah, approaches 0. Like, would you guys agree it's just getting closer and closer and closer to the where the y value is 0? Closer to the x-axis means the y value is 0. So it's getting closer and closer to 0. Well, over here, as x is approaching positive infinity, what is f of x also approaching? It's also approaching 0. That's called your left end behavior and your right end behavior. Okay? Now, this is going to be, that's called your end behavior. Now let's talk about towards the vertical asymptote. So I'm going to change colors here, see if this makes sense. What's happening as I am going this direction? As I'm approaching what number on my x's? As x approaches 0 from the left, what's happening to all of my y values? As I'm going to the left, what's happening? Right? So, yeah, so as x is approaching 0, what is f of x approaching? Positive infinity. But how do we say from the left? And how do we say from the right without having to write the words from the left and from the right? Okay? So, now, would you guys agree this is approaching it from the right and this is approaching it from the, wait, hold on. From the left, from the right. All right, so here we go. As I'm going from the right-hand side, we put plus. As x is approaching 0 from the left-hand side, so wait, negative means, just so you guys know, negative means from what direction? From the left, and positive means from the what? From the right. So if you ever see like 0 plus, that means 0 from the right-hand side, and this means 0 from the left-hand side. What is f of x approaching here? As it's going from the left, getting closer to 0, what's happening to my y values? They're going to negative infinity. All right? It's going to get real hot down there pretty quick. All right? From the right, they're going to go see Jesus. From the left, they're going to go see Satan. All right? Just joking, people. I'm just joking. All right? All right. So, right now, let's take a look at our problem. Can you guys type this one in and take a look at it? All right? We're going to take a look. Negative 2x squared plus 3x minus 7 over negative 6x squared. So I'm going to take a little screenshot of this. Make a little fraction. Go back, take a look. Negative 2x squared plus 3x minus 7. All right. Negative 2x squared minus 3x. Was it plus 7, minus 7? Minus 7. Oh, whoa. I messed up there. 2x squared plus 3x. Come on, you son of a nutcracker. I know, right? Come on. Plus 3x minus 7. There we go. And then negative 6x squared plus 9. Plus 9. Okay, cool. You guys can take a look at that. Okay, goofy looking problem here. All right. Now, there's a little rule right here. Do you guys see how these powers are exactly the same? All right, I have a feeling we might have to deal with these things called horizontal asymptote rules. I know. They're not that hard. Okay, did I mess up here? Negative 6x squared plus 9. Okay. All right. So there are rules for horizontal asymptotes. So guys, what I want you to do is I want you to put a times x to the power of m plus dot dot dot. We're going to go over b times x to the power of n plus I don't care. So what I want you guys to have in your journals, this is going to be a very important journal situation. We're going to go over the 3 rules for horizontal asymptotes. Okay? So, rule number 1. Rule number 1. If the m value, I'll highlight it. If the m value and the n value are the same. So if m equals n. So you guys see how these are the same? That's a 2 and that's a 2. Then the horizontal asymptote will be y equals a over b. So let's apply it to this rule. What's our a value? Negative 2. What's our b value? Negative 6. That reduces to 1/3. So what I'm going to do right now, I'm going to put this on the paper. I'm going to put I have a horizontal asymptote at y equals 1/3. So I'm just going to type that in real quick, and I'll go back. Y equals 1 divided by 3. And I want you to see how this right here, that this rational function gets really, really, really close to that. And if we zoomed in a lot, you would see that that is the case. Okay? It crosses over, but what's going to eventually happen? It eventually just stays where? Right over, no matter how much I zoom out, can everybody see how that stays, this graph stays close to that horizontal asymptote? That's rule number one. Rule number two, m could technically be greater than n. What does that mean? That means this power could be greater than the other power. Like, what if that was a 3 and that was a 2, or that was a 5 and a 2, or a 6 and a 2? That means there is no horizontal asymptote. So if m is greater than n, then the answer is there's none. What's the last and the only third possibility? M could be equal to it, m could be greater, or m could be less than n. So if m is greater than n, there's none. If m is less than, it's always y equals 0. If m is less than n, no matter what, your horizontal asymptote will always be y equals 0. So in this case, we have it equal to each other, don't we? Right? So right now, as it's going to the left, what's it getting closer to? 1/3. As it's going to the right, what's it getting closer to? 1/3. Okay? So what I'm going to do is I'm going to go over here, and I'm going to take a look at my end behavior. And notice, before I even chose anything, what weird fraction pops up that we just found by doing -2 divided by -6? 1/3. As f of x is approaching negative infinity, as x is approaching negative infinity, what's f of x getting closer to? 1/3. What about on the right hand side? 1/3. Now here's the thing. I'm letting you know this because our first problem, it wasn't 1/3. What was our very first problem? 0 and 0. But wait a second. What does this mean? What would be our m value and what would be our n value? So on this problem right here, could you guys put, this is like saying x to the 0 over x to the first. So m is 0, n is 1, 0 is less than 1. So our very first problem, our power was less in the numerator than it was in the denominator, and that's why it was 0 and 0 for our f of x. All right, so 1 over x is the same as saying 1 times x to the power of 0 over x to the power of 1. These mean the same. This means the same as this. And these are the powers. All right, I'm going to go ahead and hit check and move on to the next question. All right, here we go. Oh, by the way, check this out. That's a 4. That's a 5. That's a 4. That's a 5. Would you guys agree on this problem? The m value is definitely less than the n value. So if I just followed the rules without even typing in the graph, if I just followed the rules, as x is approaching negative infinity, f of x should approach 0. And as x is approaching positive infinity, f of x should also approach 0. But for some of you, it's seeing is believing. Okay? So what we're going to do is we're just going to type this in nice and neat, and hopefully you guys will see that seeing is in fact believing. But I need your help. Could you please write that down real quick so that somebody can help me type it in faster? All right, so I'm going to go ahead and head over to my graph. Going to delete this. Going to delete this guy. All right, first thing I'm going to do is I'm going to type in division sign. Okay, what's my numerator? negative x to the power of 4 plus 6x squared plus 4x, and what's in the denominator? Negative 3x to the power of 5 plus x to the power of 4 minus 8, and that's it. Can you guys see? Can you visually see how that gets closer to 0, and that's it? So what's my horizontal asymptote? Just y equals 0. And I'm going to change colors here so you can see it a little bit better. So no matter what is this graph going towards the left and towards the right get closer and closer and closer to? Y equals 0. And why is that the case? Because of this power and this power. They control everything. 4 is less than 5, which means my m value is less than my n value. And that's why, without doing any, like having to do any complicated math, all I have to do is just simply say 0 and 0. Now, let's take a look at this. Is there going to be a horizontal asymptote right here? No, there's not. Why? Because what's my m value? 2. What's my n value? 1. 2 is greater than 1, so there's going to be no horizontal asymptote. Okay? So would you guys go ahead and just type that in exactly as it appears? 7x squared minus 2x and x plus 5. 7x squared minus 2x and x plus 5. Okay? 7x squared minus 2x and x plus 5. 7x squared minus 2x and x plus 5. You look at that. Let me zoom out a little bit more, because this is where you got to be careful. All right, so guys, we're going to talk about something real quick. I'd like you guys to go ahead and write this function down. You have 7x squared minus 2x over x plus 5. Now, it's been a while since you guys have done this, but there's this wonderful thing called synthetic division. All right? How many x squareds do we have? 7. How many x to the power of 1s do we have? Negative 2. And how many x to the zeros do we have? 0. What number would I plug in? Yeah, very good. You remembered. Negative 5. What are we going to do? Drop this down. Multiply that together. What do we get? Negative 35. Add those together. We get negative 37. And you know what? You don't even have to worry about it. That's as far as I'm going to go. Oh, negative 5 times 7 is negative 35. Add those together, get negative 37. Okay? Right here, I have a 7x minus a 37. That's my that's my slant asymptote. It's called a slant, also referred to as an oblique asymptote. So watch what I'm going to do. I'm going to type in 7x minus 37 in our graph, and you'll see how how this function gets close to it. 7x minus 37. Can you guys see? I don't know if you guys, I'm going to zoom in a little bit more. Can you see the boundaries that are created, like how this graph gets closer and closer and closer to that line? This right here, guys, this is your slant asymptote. So let's ask ourselves, as my x values are going towards positive infinity, what's happening to f of x? What does it look like they're going towards? Positive infinity. Over here, as my x values are going what direction? To negative infinity. What's happening with my y values? They're going which direction? To negative infinity. So as x is going to the left, it's going down. As x is going to the right, it's going up. And that's your answer. So hopefully seeing is believing. Now on this one, what did you have to do? You had to zoom out. Otherwise, you would have missed out. Because here, what did our original graph look like? Ready? You saw this. And what would students might think? They might think this is going towards what? Negative infinity and positive infinity. But what did I have to do? I had to zoom out enough to see there was another part of the graph. Okay? So, right here, as x is approaching negative infinity, what is y approaching? Negative infinity. As x is approaching positive infinity, what's my y value approaching? Positive infinity. Okay?